So I'm going to start with a very annoying show of hands, but I'm assuming we're at KCD UK. So I'll ask everyone to put their hands up, and then put your hands up, come on. Put your hands down if you're not running Kubernetes. Okay. Hands down if you're not using microservice architecture or service-oriented architecture. Hands down if you're not using GraphQL. All right, this is the perfect room, I love it. So this talk is a secret talk about GraphQL, but focused on microservice architectures running on containers with Kubernetes. And this is my mission today. Has anyone ever deployed a microservice that is a single column in a database? Yeah, maybe I'm insane. But I want to convince you that this is not the worst idea and actually makes a lot of sense as we adopt more and more microservices. Now, I'm not going to ask you to show your hands, but microservice adoption is everyone in cloud native is at some point in that journey to be in microservice or service-oriented architecture. To the point now where we look at companies like Google, Meta, Netflix. I mean, I could just sit and list companies for the next 30 minutes and the talk would be done, but they're at a stage now where they have not just thousands, but tens of thousands of microservices. And there becomes a lot of challenges in scaling microservices, even at dozens, right? So this is applicable to anyone who's even early in that journey where they just have 10 microservices or 30 microservices. If you don't know who I am, my name is David Flanagan. I'm from Glasgow, the better city. Wrong room. I have the Rock Code Academy. It started off as a YouTube channel where I just make videos on cloud native technologies. I want to make Kubernetes accessible to everybody. So if you've ever struggled with microservices, Kubernetes, or any of the challenges, and there are many of them, that come with this approach, please check out the YouTube channel and, more importantly, check out the website. We're now at a stage where there's over 500 videos, which is over 650 hours of content on the cloud native landscape. I'm not going to show the landscape document. We've all seen it. It's super scary. It grows exponentially at a rate none of us can learn, right? You're not expected to learn all of this stuff. I just want to make it easier for you to learn the stuff that you need to learn. So please check it out. Now, we're going to start with a very contrived example for GitHub, where we have issues, comments, and projects, right? We all use GitHub. We know it's there. We all use GitHub issues. We possibly contribute to open source. And you may see some sort of ERD like this, some sort of entity relationship, where our issues can have comments, they can be part of a project, and we never get this right the first time. At some point, we need to evolve our schema, right? Our requirements change, our project is evolving, and all of a sudden we're like, all right, okay, what if our project needs a status? What if our project manager, or product owner, whatever we call it these days, has decided, well, our issues have a state, why doesn't our project have a state? Maybe our project should be on time, maybe it should be delayed, maybe it is cancelled, right? Whatever we want. At some point, we need to add a new column. Now, with microservice architectures, we could add a new column. It wouldn't be that hard. Who enjoys schema migrations? Nobody? All right. Of course not, right? There's a whole bunch of heuristics, there are rules that we need to follow in order to do a safe schema migration. We never rename columns. We only add columns. We only do this. Everything should have a default value. Right? Nobody knows all these rules because technology evolves and the rules change. So, well, a naive approach could be, and I'm not saying a wrong approach, right? If anyone's sitting here going, I've got a microservice and I've done this, that's okay, right? I just want to show you that it's potentially a different route. So this is okay. But there are challenges with a SQL migration. Right? Not everybody knows this the first time, and in fact, I've been doing this for over 20 years and I still make mistakes with SQL all the time and lock-in semantics. But if you want to do a safe, zero downtime migration or modification to any table within a SQL database, and I'm using the two biggest ones here, which are MySQL and Postgres, then you have to make sure that the column is only ever added at the end of the table. And you may not even be aware that you can change that, but you can. You have to make sure there's always a default value, even if it's null, which may or may not make sense depending on the column that you're adding to your table. And you have to make sure there are no constraints or rules on the values for those columns. And that is obviously quite difficult to do if you want to have a database abstraction or at least some sort of validity concerns encoded at the database layer, which is generally quite a good thing to do. So as long as you follow these rules, you can add a column and you will have a zero downtime migration and you can all go to the pub and enjoy the rest of your day. But unfortunately, that is a very simple change of adding a column. And schema migrations can actually be quite difficult. Sometimes we do need to rename a column, or we want to change the column type. Maybe we started off with a very naive integer, but we actually need float-based values. And this is where we start adding on all these rules again. Okay, well, we only ever add columns. So we're not going to rename or change the column type. We're going to add a new column. We're going to migrate all the data. And it just becomes a lot of work. And then this becomes tribal knowledge within your team about why we have a state column and a status column and a status 2 column. We've all been there. So schema migrations are just hard across the board, especially when we constrain ourselves to doing it within a table that already exists. Which is why we have all of this tooling, and I'm only listing 4 here, but I could easily have made this a 30+ listing of tools. And I've tried to kind of, satisfy the old Java developers with Liquidbase and Flyway, but if you're cloud native in that KCD, hopefully you're writing in Go, and well, actually you should just migrate to Rust right now. But hopefully you're using Schema, Schema Hero, which is written in Go. It's an operator that runs in your Kubernetes cluster and manages your database tables for you. Or at the very least, you're using something like Atlas, which is a HCL Terraform-like approach to doing schema migrations. These are cool tools, but they don't remove the problem, they mask the problem. They give us tooling to make sure that we don't make the mistakes that maybe are ingrained in tribal knowledge within our teams and our organization. So I propose to you, what if instead of doing a relatively simple-ish add column on a database, what if we spun up a new service? And this service could just be responsible for a single column, which is the state of a project, but it does have foreign key constraints to a degree where we reference the project and the project service. We have no schema migrations, we don't have to worry about downtime. Actually, you get a really nice benefit with this approach, and that if I decide the status is the wrong name for the column, I can spin up a new service, copy the data, spin it over, zero downtime across the board. And I want to show you how this is possible using the tooling that we have available to us today. So, I asked you all to show your hands, and I think only 2 hands are up for GraphQL. So I am going to cover a few of the basics of how GraphQL works, but specifically, what I want to show you is that when we're doing microservice architectures, there really is the right way, in my opinion, to do read models. And I think GraphQL is a really good fit for this. Now, if any of you out there are going, well, what about gRPC and what about REST and API gateways and all that stuff? Some of this is possible with those technologies. And if you want to go into that in more detail, ask questions at the end, or just find me at the after party. I'm happy to sit and talk about the flaws with all of these approaches. And this approach is not without its flaws, but I'm going to try and make them very transparent as well as we go. So, GraphQL Federation works, and we have some sort of client query that comes to a router. The router is our API gateway for GraphQL, and it can do some very, very sophisticated things. To the point where we have something called entity resolution, which knows if we are looking for a project to go to the project microservice. We have something called a key that I'll go into in more detail shortly, but this says if you ever need to find a project in any query, you find it at this service here. We then have our issues service and our status service, which is actually extending our project entity to provide new functionality as we expand our rules. All of this happens behind the scene before eventually it spits out a response, which comes to whoever called the query. So a lot of this is magic that just happens behind the scene by the GraphQL router that you never really need to worry about. But of course you do need to worry about it because there's a whole bunch of trade-offs and performance optimization things that you need to know to make sure that you don't DDoS yourself, essentially, as your clients are coming in. GraphQL looks like this. It's a really cool language where we can say, I want to get all the issue details. The name here is completely irrelevant because the queries are whatever I name them, so I know how to parse the response when it comes back. But the entities within are important and are referenced and handled by the router. Specifically here, we have a read model for issues, which actually has a nested entity resolution for comments. This is weird for people that are not familiar with GraphQL, But because the GraphQL router understands the relationships of every entity within the system, we can nest these as deep as we want. Some of you will be going, that sounds quite scary, and it is. But again, we have rules and regulations, constraints that we can put in place to make sure we don't denial of service attack ourselves. So here, the router knows that we have issues, and the comments are related to issues, and we can fetch them if we have enough information to be able to resolve the query. Then we have project details. Right now, our project only has a name and a description, but if we do this right and we deploy our new service that extends the entity with our status, we can do something like this, where we can say, okay, I want to get the project, but I also want to get its issues and its comments. And again, this query is not something that you, as a back-end developer, and I get making some assumptions about the people in the room, you don't need to worry about what the query paths are. You're just saying we have these entities available, they can be resolved, and the client gets to make up whatever shape they need to satisfy their application, the front-end application. There's a lot of power and flexibility. These are things that we don't have with REST or gRPC, where it is a fixed view of the world. It has to be shared with the front end and the back end. GraphQL allows us to have this facade where we say, you can query whatever you want. I don't really care. And we will have a router that handles this for us. Now this works because GraphQL has something called directives. These directives are, for example here, key. This is how entity resolution works. When we define a type of project, we see that it is keyed on an ID. Really simple, right? If I want to find a project, I just need to know its ID. What's really cool about GraphQL is that this supports composite keys as well. So it may be that if I want to fetch an issue comment, I might have to know the issue and the comment ID to fetch that one particular thing. So composite keys are well supported, well documented. I'm just not showing an example for brevity. Now, we also have requires. So when we do entity extension, we can't just say we can extend project without knowing the ID, right? If we're going to extend some entity, we need to know its ID. And again, this supports composite keys. If we have sophisticated entities or extensions across multiple entities, we can handle all of that with composite key directives. So if we want to extend the project type, we can have a microservice that says we extend the project type as long as we have the external identifier. So this external directive is another directive that we're not going into in a lot of detail. It just says this is owned by another service, but if we have it, we can use our service to provide new information for that service. In this case, we have a status and an updated at that says this status was updated at whatever time. Now, GraphQL queries can be very complex. They can be deeply nested, where issue, back up, we could have a project that requests all of the issues attached to the project. That issue can then request comments. That comment can then also sub-select its issue again, going back up the tree. You can imagine that issues and comments could actually can indefinitely recurse, where issues ask for comments, comments ask for issues, because we don't control the query on the front end. Now, while we can protect that at the router, and I'll talk about that towards the end, we can also use the provides directive for hot paths. So if we know that whenever someone requests comments, they're probably going to request the user that did the comment as well, you can say that we can actually satisfy that without going the extra hop to the extra service, because we have a shared cache where the comment service is allowed to fetch read-only user information. Now, I know this can get really complex. GraphQL can be very complex, but with that complexity comes the ability to optimize and hopefully make your life a little bit easier. So, now, there's a lot of moving parts here, but I don't think these are moving parts that you aren't already dealing with. Now, if you have a microservice architecture, we have this kind of cloud native promise that everyone gets, like, you have to sign the agreement before you can say you're cloud native, right? Where it's like, we are going to write super simple services that are less than X number of lines of code. You know, who wants to define what a microservice is? Anyone? Right. We can't. No one has ever said what micro is micro enough. However, we're promised that our lives will be simpler. Now, that complexity doesn't disappear, as we all know. If you have more than one service, The complexity from each individual service does disappear, but it's pushed down to the platform layer or the infrastructure layer. We have to handle service discovery, retry logic, we have to have rate limiting, we have circuit breakers, we have service meshes, we have RBAC and authentication and authorization rules that have to be ubiquitous across every single microservice. So it's not a free lunch. And GraphQL Federation is the same. We do simplify the lives for our clients, our mobile applications, on our websites on the front end, but the complexity is just pushed down, right? It's not removed. And I just want to kind of make that clear as well, that you are taking on a operational burden to some degree when you adopt GraphQL Federation. Most of this is handled by the router via the query planning and the entity resolution. So what's really nice about the router, depending on the router that you adopt, and there's a few different open source options you can use, is that when the query comes in, it will try to work out all of the different entities. It will then cache or query plan as much of that as possible. And I always try to think of this in a real example. If we're GitHub and we query all of the comments on an issues and all of the users that make the comments, do we want to send 50 requests to the user service for the 50 different users that make the query or left the comments? No, right? We want to send one request where we have 50 IDs and say, give me all these users back. And a router will handle all of this for you, kind of for free. Now, what's nice about this is that the router can be independently scaled. You can deploy as many routers as you need. You can handle the caching independently at a service level as well. So you can have your user cache, you can have your comments cache, you can have a cache that satisfies all of them, or at least different boundaries that you define. It's really up to you if you want to do this at the router level, the entity level, or to some degree, you can even do it at a column level. Again, if you have hot paths that you, as a platform engineer or backend developer, can identify, you build the cache that suits, and again, the front end doesn't really have to worry about it. What's really nice about this is that we can, determine where we're happy to have our fault boundaries. So nobody in here is sitting with 6 nines of reliability. It's just not going to happen. You have to determine where you're going to allow those faults. There are maybe paths in your GraphQL query. You say it's okay for this to fail because our application can still be used, it can still be successful, and we're willing to take a hit on this certain query path, and that can all be encoded in GraphQL via the router as well. All right, we'll skip this one. So, the other very nice approach to this is that something we lose out on a lot, again, I'm making assumptions about us being mostly back-end developers within a room, maybe writing in Go or in Rust, is that there's this whole world out here of TypeScript and Node and JavaScript and Bun and Dino and Vite, etc., that are deploying to Vercel or Netlify or Cloudflare. They're getting all of this free compute to a certain degree that is edge scalable, right? GraphQL makes this possible too. Because you can write your GraphQL resolvers in these languages, you can actually, and I'm going to try and show off some of how the Raw Code Academy works because I have over-engineered this for my own craziness, I guess, to a certain degree. But everything is deployed on Cloudflare, which means it's in over 300 different edge locations around the world. So if you're in Australia or if you're in Argentina and you're across the Raw Code Academy website, my goal is to have that response be less than 50 milliseconds. And GraphQL makes this possible as well, via leveraging CDN caching as well. Now, a lot of this requires sophisticated CI/CD. I'm hoping that we've all got this controlled in 2025 and we're not also running, whatever random deployment mechanism saying that we don't deploy on Fridays or anything like that, because if you have a microservice architecture and your deployments aren't automated, you're probably sitting here in a world of hurt. And you've probably got your laptop on your knee because you're waiting for that next Slack message saying that your system is down. So use GitHub Actions, use Jenkins, use Dagger, I don't know what you're using, but just make sure you're automated, all your deployments are automated and hopefully happening multiple times per day. Because in a microservice architecture, if you don't have the basics down, adopting something like GraphQL Federation is just going to cause you more problems in the long haul. And again, I don't want anyone to leave here thinking, oh, that guy said I should be doing this, so I'm going to do it, and then you don't get any sleep for the next 6 months. So, you really do need to have the basics and the primitives sorted, and automation is a very good first step for that as well. We also need to be able to control the scaling of these services. So if you're going to extend an existing entity with a brand new service, make sure you do have the ability to scale that independently. It's going to be very important, especially for query paths that are hot and do require a lot of action from the user. All right, now I've got the 10-minute warning, so I'm going to try and speed up because I did want to show you how this works for real life. But there are trade-offs. I will make these slides available. Again, it just comes down to making sure that you have automation as a bare metal fundamental to everything that you're doing. Where things get tricky is that autonomy within a microservice architecture is quite difficult. If you deploy the project service and you're responsible for that, and someone decides they want to extend your service within the field, you need to make sure via GraphQL directives, you can actually make up your own directives. You can have ownership, you can have SLAs, you can have SLIs, SLOs, whatever. You can embed that all into the GraphQL IDL, and it just means that anyone who queries your graph or has access to the schema SDL can get all of that information right away. And again, you can automate this with runbooks. You can have a runbook that pulls down the schema. You can say, I have a problem with this service, and it tells you who is responsible for it and who you need to go speak to on Slack. So infinitely flexible as well, even if it's not without its trade-offs. Right, let's show you how this works. So I am using something called Cosmo. It is a GraphQL router. It's written in Go, which means it's cloud native by default. And it's really hard to see this now. I have a whole bunch of services. Now, the Rockwood Academy, think of it like YouTube. It's my own personal YouTube to deliver educational content to people. So I have videos, and if I scroll down, hopefully videos is on the first page. It's not. We have a video service that has the title of the video, it has the length of the video, and it has a URL to get that video via M3U8, which is the playlist file. The video service is really simple, and as I add new functionality to that, I'm doing it via entity extension in GraphQL. So we have episodes, which is a video that is part of a show. This is just a very simple service where it has a video ID and a show ID and some sort of episode code, so that you can query something like Cloud Native Compass or Rockwood Live and say, give me episode 4, and it will handle that resolution for you. We have emoji reactions. You can go to the Rockwood Academy website. If you're logged in and you're watching a video, you can sum it up, you can heart it, you can add a beer emoji, whatever you want, right? This is a microservice that just has a video ID, a user ID, and some sort of emoji Unicode. Where I started to push this, maybe to my own detriment, but also in the name of education and fun, I thought, okay, well, a show has hosts. Now, I'm sure every sane person in this room who wants to add hosts to a show would just go to the show service and add a new column of host or hosts, right? I decided to do a distributed join with a new microservice where I have the show host service, which all it has is a show ID and a person ID, and this now becomes the host. We also have a guest service. We actually have it's more agnostic than that, but you can think of it as a guest. So if it's a guest on an episode, I can say this person was on this episode and this was their role, which also works. We also attach technologies to videos. So I want videos, if you come and search for Knative, I want to be able to show you all the videos on that certain technology. That again is all done via extension and microservices. So you can see here that it's kind of cool, but it looks complex off the bat. If we go to the overview, and this is not really going to look good on this screen at all, but you can kind of see here, we have the API coming in, or at least any requests hit the API, and these numbers are not entirely accurate. I'm not sure why they're so slow, but you can see as the requests go to each different service as well. Now this is just the top 5, so you can see that most of the time people come to the website, they're requesting people, show hosts, episodes, and videos. So I can kind of make some assumptions about the query path here, being that people want to understand the composition of videos. If we pop over here, we can actually run a query, and I'm going to try and show you all the service boundaries that exist. So the simple query is just to fetch all videos with a title. The query plan's not working, but we have the title of the videos here. I can then say, is this an episode? And does it have a show? And does that show have a name? And does that show have hosts? And does that host have a forname? right? And because it's the Rockwood Academy, it's really just me. We can also then suggest, let's see, chapters, which has a start time. Now this is going to look probably ridiculous on this, but let's see. And that's very slow. I think I need to fix my infrastructure. But we have here this title, which is coming from the video service, the episode, which is a distributed join, which fetches information from the show's service, and there the show has a name. Then we have the host, which is also a distributed join, which is going through and collecting information. If you were thinking it get a little complicated, it's fetching the join information, which is the show and the person ID, coming back to the router, looking up the person in the person service to get the name, etc. A lot of confused faces here. But this is very performant. Well, this query was a little bit slow. I think that's my problem, not GraphQL problem. The router is very smartly only looking up my user information once, even though as I scroll down, we will see my name over and over and over again. And I can identify these hot paths and drop in a cache if I want, as well as the router using its own cache. So if I run this again, for instance, I don't have caching set up, my apologies, but I can hook this router up to Redis, where it would not run these queries again against the microservices. So, I am running out of time, so we'll move forward. I think what the really cool thing about this is that GraphQL is a fantastic technology. Federation is very sophisticated, and I think it's the ideal path for all read models within a microservice architecture. To the point where I think GraphQL can actually become an IDL for all of our microservices. This is one of the things that we struggle with, and we're starting to lean into tools like Backstage and other platform engineering tools that give us this, pane of glass to understand our architecture. But if we can define it all in GraphQL, and we can add our own directives, we can add our SLOs, our maintainers, everything, this becomes a really important infrastructure pattern that makes platform engineering a lot easier as we grow our microservice architecture. Federation makes it so that instead of using SQL migrations and modifying existing code, we can add new code. The really cool side effect here is if we make a mistake, maybe we decided to add in a project status, maybe we got the column type wrong, maybe we got the data wrong, we can just add a new service. It's really easy just to do an export from a SQL database and stick it into a new one. You can satisfy or run both services at the same time. And there's actually GraphQL directives that allow us to handle migration of data across our graph as well, that I'll talk about in just a second. Makes it really easy to scale our services and add our teams. So I would encourage you all, if you're not, I know you're not using GraphQL because you all put your hands down, but I think this is a really powerful pattern, and I'd encourage you all to start playing with it and experiment with it, because what we have with our existing tooling with REST and gRPC, I don't think it's good enough. And I've been very specific today to talk about read paths. Read-only models. Should you be using GraphQL mutation? I can't speak. Should we be using GraphQL mutations for our write path? I do not think that is the right path. Use gRPC, right? There's much better ways to do write paths, workflows, using temporal. Again, I can talk about all of this afterwards or at the after party. Just come up and talk to me. More sophisticated things we can do is there are directives called override, inaccessible, and deprecated. So if you need to deprecate a service, deprecate a column, or even just say this service doesn't exist anymore, I do not want the project status to come from the project status service. We now have project status 2, or even 12, I don't care. We can use annotations to make sure the router knows how to fetch that information without your front-end teams ever having to worry about what you're doing on the back end with your SOA. Thank you so much for your time. I've got about 1 minute left for questions.